Alright, in this lesson we're going to be talking about identifying the domain and the range from different types of graphs. So we've talked about this a little bit before, but those were really straightforward examples where there were discrete points and you really just had to write down the x and y values. Actually, that's what we see in these first two examples. We're just listing out the domain and the range. Domain is the x, range is the y. So we're really just listing out the coordinates for the x for the domain and the y for the range. Actually, we're just going to do those two examples and then we'll get into trickier examples when we see those graphs. So the domain for the first one is really just writing down the first number in each of these ordered pairs. 0, -8, 4, 1, 0. 0, -8, 4, 1, and 0. You don't really need to list 0 twice. If it repeats, you can just list it once. And I'm going to put these in brackets because we're going to deal with this a little bit later. But this is kind of getting into set notation, set builder notation. The range is just the y value, so we're just going to list out the y coordinates for each of these ordered pairs. And I'm going to say this a little bit differently. It's saying the exact same thing, but I'm going to write it in set builder notation. So I'm going to say y basically is all of these points. It's 9, 7, -2, and 8. I see that 8 repeats twice. I don't really need to write it twice, so I'm just not going to on that second one. It's the exact same thing as the first one. I'm just listing out the points. It's just phrasing it a different way. It's just saying y is all of these points. Same thing for the second one, domain and range of that relation. We're just writing out the x and the y values. This one I have to read it from the graph, but it really doesn't make it any tougher. You're just reading the x coordinate for each of these. So I have -3. I'm going to say that x is, oh, that's the way that's writing. X is these numbers, and you could write an equal sign if you wanted. You might see it this way also. X equals these 5 numbers. It's -3, -2, 0, 1, and 2, 3, 4, 5. That's 5. It's just a different way to see it. It's saying the exact same thing as the first one. It's just listing out the coordinates for the x values. For the range, it's just talking about the y values. So I'm looking at -5, -2, 0, 3, and 6. You can write it in either of these forms. I just want you to be familiar with both of them. Now we get into some trickier examples where it's not just scattered points. These were both just scattered points on the graph. On the next two, we're going to be talking about a straight line. Lines go on forever. That's what the arrows mean. They go on forever in both directions. That's what the arrows at the end of the line actually tell us. So when I'm talking about domain, I'm talking about how far to the left does it go and how far to the right does it go. Well, I'm talking about a line, so it's going on forever to the left. And it's going on forever to the right. So it goes on forever to the left side. When I'm talking about going on forever to the left side, think of the biggest number you could possibly imagine on the left side of the number line. Really, we're going to be talking about -infinity there. It's going on forever in the negative direction. When I'm talking about the right side, it's still going on forever, but now it's going off in the positive direction, so that's a positive infinity. Not much better. Now, when I'm trying to say that as a domain, again, there's two different ways I can write this. One is just writing it with an inequality. The other is writing it in set builder notation. So I'm going to write it with an inequality first. I'm saying that all of my x values, my domain values, are in between -infinity and positive infinity. So in between -infinity and positive infinity. X is greater than -infinity, but it's smaller than positive infinity. It's squeezed in between all of those numbers. When I write that in set builder notation, there's just another way that you could see this. You'll see it listed with the real number symbol. So we'll say that x such that, that's the way we read that line, saying x such that x exists as a real number, or x is an element of the real numbers. It's another way to say x is any real number. It's in between negative infinity and positive infinity. It doesn't have any boundaries at all. When we're talking about the range, we're talking about how far down or up does it go. It's kind of the same thing. It's going down forever, and it's going up forever. But thinking of it the same way, it's going from negative infinity up to positive infinity. And I can list this in the same kind of way, except now I'm talking about the y values. So I'm going to write it as an inequality first. Negative infinity is less than y, and y is less than positive infinity. Or we could see this in set notation, y such that y exists as any real number. Y is an element of the real number system. It's any number that we can imagine. On the next one, we just see a horizontal line. So when we're talking about how far to the left does that go, that goes off forever to negative infinity. Talking about the right side, it goes off forever in that direction. That's positive infinity. So I'm going to write this again. I'm not going to write both ways every time. I'm just going to choose one each time. I'm going to say that x is an element of a real number system. Again, you could choose the inequality. If you like writing it as an inequality better, use that one. On a multiple choice test, you obviously have to recognize those as the same thing. When I'm talking about how far down that goes or how far up it goes, it actually doesn't go up or down at all. It stays at the same number the entire time. It's staying flat straight across at 3 the entire time. The range is 3. It goes down to 3, and it gets up to 3. Doesn't really change at all. This one you really have to write in set builder notation. You could just write y equals 3, or I'm going to write it, this is just a nicer math way to write it, y exists such that y equals 3. We're talking about it as y and x because this is the range, this is the domain. So you have to make sure that you're labeling it with the correct value, or the correct variable. Otherwise, it's not really clear if you're talking about domain and range. The next two are going to be talking about curved lines or lines with a boundary. So we're talking about how far to the left or right does this go for our domain. We're talking about how far to the left does it go. Well, that's going to go off forever in that direction, forever in that direction. So it's going from negative infinity, positive infinity. And I'm going to write this one with an inequality. Negative infinity is less than x, and x is less than positive infinity. Again, if you want to write set builder notation, that's the same exact thing. Feel free to do that. Now, how far down does this go? This stops right there at positive 1. But it goes off forever in the vertical direction. It goes off forever to positive infinity. I'm going to write this as an inequality. I'm going to say that 1 is less than or equal to y, because y actually gets down to 1. It could equal 1. There's a point there where y does equal 1. That's why I include the less than or equal to sign. Y never gets to infinity, so we never write a line underneath those two. And y is less than positive infinity. If you didn't want to write the second part, you really don't have to. You could just say 1 is less than or equal to y, and that means the same thing. Y is any number bigger than 1. That includes every number up until infinity and beyond. You could also write that in set builder notation. Usually you list the y first. Usually you list the y first, so I'm going to write that a little bit differently. I'm going to write that as y such that y is greater than or equal to 1. Again, it's just a different way to write the exact same information. And on the next one, we're talking about domain again. We're talking about left and right. So this goes off forever that direction, forever that direction. It's going to continue going off to the left forever and to the right forever. So I could say that x is a number such that x exists as a real number. X is an element of the real number system. Any real number works. When I'm talking about the range, I'm talking about how far up or down it goes. Well, that's going to go down forever. That's what those arrows are telling us. That goes down forever. That goes down to negative infinity. And it only gets up to this point, but it actually does hit that point, so it gets up to 3. So I'm going to write this in set builder notation again. Y is a number such that y is less than or equal to 3. And on these next two, we're going to have more than one boundary. It's really the same situation. We just want to write it as an inequality or write it in set builder notation to show all of the possible x and y values. When I see domain, I'm thinking about how far to the left does it go and how far to the right does it go. It's going to go on forever. It's going off to negative infinity as far as it possibly can, that direction, and positive infinity off to the right. So I'm going to say x is a number such that x is a real number. It's any real number that we can imagine. We can see that the range is not going to be any real number. We have a boundary at the top, and we have a boundary at the bottom. It's capped at the top and capped at the bottom. That means it's going to have a range in between those two numbers. It gets down to negative 1, 2, 3. The y value there is negative 3. And it gets up to a positive 3. So it's in between those two numbers. I'm just going to write this as an inequality. I'm just going to write that negative 3 is less than or equal to y, and y is less than or equal to positive 3. Y is sandwiched in between those two numbers, but it can get up to those. That's why you have to include less than or equal to, and you have to put that line underneath because it can actually get up to 3 or get down to negative 3. How far to the left does that line get? Well, it gets to 4. Sorry, excuse me, negative 4. And to the right, that goes on forever, so that's going off to positive infinity. I'm going to write this the simplest way possible. X is greater than or equal to negative 4. It's any number bigger than negative 4. It goes off forever past negative 4 in that direction. It gets down to a y value of 0. But again, it's going to continue going off forever in that direction. It's going to go off to a positive infinity. So again, I'm going to write this as simply as I can possibly. Y is greater than or equal to 0. All right, now we're going to be talking about lines that are continuous on an interval. Basically, you could see it like this. The first example is just a scatter plot that's just connected. Or you can see it as a second one where it's just a section of a curved line or a section of a straight line too. It's just saying that it's going in between those two numbers. It's kind of like this one where we have to consider two different boundaries. Except we really have to pay attention to the endpoints on these. On the first one, we see that these are filled in circles. On the next one, we see that we have an open circle. So we're going to compare those two. How far to the left does this first one get? So we're talking about domains, we're talking about left and right. It gets to negative 1, 2, 3, 4. Negative 4 to the left, and 1, 2, 3, 4, 5, 5 off to the right. So our domain can be described as x such that negative 4 is less than or equal to x, and x is less than or equal to positive 5. So y is talking about how far up and down it gets, so we're talking about the bottom point and the top point. That gets down to -1, 2, 3, 4, -4, and up to 1, 2, 3, +4. So y, oops, right, I said bottom number first, -4 is less than or equal to y, and y is less than or equal to +4. This is called a compound inequality when we describe two inequalities with that same algebraic sentence. It's really just saying that y is in between those two numbers. Alright, on the next one, how far to the left does this get? So it's getting out to this point, but it actually doesn't get there. That open circle says it's approaching that number. It doesn't actually get to -5. So it almost gets to -5. I'm going to say it's approximately -5. That's what that little squiggly line means. It's almost getting to -5. And to the right, it almost gets to -2. Doesn't quite get there because of the open circle. Getting all of the points up until there, -2.0000, as many zeros as you can imagine, and then a 1, but really there's no limit to the zeros. It's just getting right up to there, but not quite getting there. So our x value is greater than -5 and less than -2. We don't put the or equal to sign there because we have an open circle. It's just like on a two-dimensional number line. Sorry, on a one-dimensional number line. When we see an open circle, we can say that like that is x is greater than 1. It's not actually hitting, sorry, positive 1. It's not actually hitting 1. It's all the numbers bigger than 1. It's not or equal to. Same kind of thing in the y direction for our range. So it gets down to a -4, almost. And it gets up to a +4, almost. So it's between -4 and +4. The only difference about writing that in step builder notation and writing it just as an inequality is the mathy part in front. It's saying y is a number, y is some number, such that y is in between -4 and +4. That's the only set builder notation part that you really have to focus on. Alright, the last one, we see a trapezoid there, so we're talking about the domain and range of that thing again. It's just talking about how far to the left and how far to the right does that get. So we're talking about the leftmost point, that's there, and the rightmost point, that's there. So that's going in between 0 and 6. So our x value is greater than or equal to 0, but it's also less than or equal to +6. And let's go with the y value gets down to +1, and it gets up to a +5. And it's actually hitting those points. You can see these dots are filled in there. So that's why we're putting the or equal to part of this. We're saying that 1 is less than or equal to our y value, and y is less than or equal to 5. It's in between 1 and 5. It's just describing that with an inequality.